This is lesson 7.1, solving linear equations by graphing. The solution for a system of linear equations in two variables is an ordered pair that satisfies both equations. In other words, the point where they intersect. This is one method to find the intersection of two lines, and that is to graph them. So when you have a system of linear equations, that means you have two or more equations. If you graph them and find where they intersect, that point should be a solution for every single equation. So here's the method we're going to do. We're going to graph both lines and find the point of intersection. And then you're going to take the coordinates of the point and substitute it back into both equations to make sure that it works. So for example, here's a system of linear equations. X plus 2y equals 7 and 3x minus 2y equals 5. To find the one point that they have in common, the solution to both of them, we first need to rewrite both equations in slope-intercept form to graph them. So for equation 1, you want to get y on the left-hand side. So we're going to have 2y equals, subtract x from both sides, the opposite of x plus 7, or y, when you divide by 2, is negative 1/2 x plus 7/2. The second equation becomes negative 2y equals negative 3x plus 5. Divide both sides by negative 2 to get y equals 3/2 x minus 5/2. Now we're going to graph them. Here you can see line 1 and line 2, and that they intersect at the point 3, 2. This should be the solution for both equations and for this system. So we're going to substitute it in and check. 3, 2 does work in both equations, so it is the solution to the system of linear equations. Since there's one solution, they call that a consistent independent system. We probably won't use those terms any more than just mentioning them here, but the fact that they're independent means that the lines are independent, they're separate from each other. And that consistently they're going to cross there. That's where they get consistent independent system. Let's find the solution to this system. We have negative x plus y equals negative 7 and x plus 4y equals negative 8. We're going to follow the same method here. Write the equations in slope-intercept form, graph them, find the intersection, and then check the solution. So the first equation simply becomes y equals x minus 7. The second equation, we move x to the other side, so it's 4y equals negative x minus 8. And then you divide by 4. So y equals negative 1/4 x minus, well, that's not 8, that should be 2. So let's rewrite that. It should be 2. When you graph both equations, you can see from the graph that they intersect at the point 4, negative 3. So you want to take that point and substitute back into both equations to make sure it works, and in fact it does. Now, this isn't exactly the simplest way to find the solution to a system of linear equations. It's not the fastest way either, or the most effective. You can already see that it's really going to take a lot of time to work through these problems. It does work, though. Okay, so when you're beginning to find the solutions to systems of linear equations, this is a good way to start so you can see what you're actually finding when you find the answer. You're finding the intersection of the lines. In the upcoming sections, I'll show you easier and more accurate ways to find solutions, if in fact there is a solution. Now let's take a look at this word problem. The Parks and Recreation Department in your hometown offers a season pass for $90. And as a season pass holder, you pay $4 per session to use the town's tennis courts. Without the season pass, you'll pay $13 per session to use the tennis courts. Write a system of equations that reflects the total cost of using the courts for X sessions. Okay? Now, in the case when you don't have a season pass, the total cost is going to be y equals 13x, where x is the number of times you use the courts. On the other hand, if you buy a season pass, the cost is going to be $90 plus $4 every time you use the courts. So that equation becomes y equals 4x plus 90. What you want to know is when the cost will be equal. That is, when will it benefit you to buy a pass to use the tennis courts? So what you need to do is graph both equations and find the intersection. Why don't you try to do that on a piece of graph paper? When I did it, I found that it crossed at 10. That means after 10 sessions, at 10 sessions, the cost is equal. Now, what does that mean as a practical matter? Well, it means that if you're planning to play more than 10 times, you actually should get a season pass because the cost will be less after that than paying the $13 per session. In this word problem, a business rents inline skates and bicycles, and during one day, the business has a total of 25 rentals and collects $450 for the rentals. Find the number of pairs of skates rented and the number of bicycles rented. Well, first we're going to write the linear system. If X is the number of pairs of skates rented, then Y will be the number of bicycles rented. You know that the total number of rentals is 25, so X plus Y equals 25. Let's write an equation for the amount of money that you're bringing in, and that would be 15X plus 30Y equals 450. You know you raised $450 during the day. 15 is for each of the rentals for the It's $15 per day for the inline skates and $30 per day for the bicycles. That was actually given in the problem in the book. When you graph both equations, you'll see that the estimated intersection is at 25. Okay? When you check that in both equations, it does work, so that is in fact the solution. But what does it mean? Well, remember what X means and what Y means. If X is the number of pairs of skates rented, then it means you rented 20 pairs of skates and 5 bicycles. On the following slide, you'll see the graph. Here it is. So you can see the green line dropping and the red line dropping. I only used quadrant 1 here because, of course, you're not going to have negative rentals. A lot of these problems, because they're logical and practical, will only be dealing with positive numbers, so I just used the first quadrant here. You can see from the graph where they intersect, but you can also see that if you're inaccurate in your graphing, that you're going to be off in the numbers that you get. So you have to be very careful when you're graphing these. Graph them as big as possible and be as accurate as you possibly can when you're drawing those straight lines.